I'm joined today by Jan Zalasiewicz, a geologist at the University of Leicester. Jan, it's so great to speak with you. I've read with great interest and seen your videos with great interest about what you describe as the anthropocene, an era in which you believe we currently are on Earth. For people who may not be familiar with your work, let's start there at the broadest possible point. What is it that you're describing?
We're looking, colleagues and I, who were working on this relatively new idea of the Anthropocene, which we are studying as a potential new geological epoch of the Earth, basically taking different kinds of environmental change to the physical structure of the Earth, to the chemistry, and to its biology, and translating that, into geology, if you like, to see what kind of record of rocks and fossils we will leave behind us, um, uh, to show how different or similar, the current Earth is by comparison with some of the big geological changes of the past.
I've read a fair bit of sort of what's described as prehistory. And one of the most interesting elements of prehistory to me, and this includes looking at the formations of our planet, is that there seem to be long periods of time in the geological history of our planet that we will likely never know much about. In other words, because of the geological realities, we just don't have much evidence that we can find to sort of suss out some of the details of what was going on our planet at particular points in time. Talk to me a little bit about what you see being available in the future to figure out what was going on currently on Earth. In other words, is the type of evidence that will be left behind from industrialization and what is currently happening on Earth, how will that compare to what we can now determine about prior eras on Earth?
Well, that's a great question, and it does go to the heart, if you like, of geology and the processes on Earth. Um, we have a pretty good idea of what kind of things get preserved in strata and what don't, and even where they might get preserved and where they won't, based on our experience of strata. You're quite right. There are some parts of Earth history where we know very little. The first billion years of Earth history, almost all the rocks have been changed, reworked, made unrecognizable, so we have little evidence. But after that, we have a pretty good and increasingly good record as we go towards the present, particularly over the last few 100 million years of Earth history. And if we, let's say, take our current landscape and see what will fossilize and what won't, well, one would predict that, let's say, San Francisco will not fossilize because it's on a part of the crust that is rising, that is being eroded. So there'll be little bits of San Francisco which will form pebbles and sand grains and mud flakes, in the Pacific Ocean, out there. So that has little chance. But somewhere like, let's say, New Orleans, which is on the Mississippi Delta, which is naturally subsiding, but the crust is subsiding. So the delta, if you like, is being buried under new layers of sand and mud, and that's a process that's been going on continually for millions of years. And in environments like that, very delicate structures can get preserved. Fossil leaves and twigs, and that's a kind of an environment. You find dinosaur footprints, things which are, very delicate, can be washed away in an afternoon. And yet, if you bury them, with sand and mud, and that sand and mud keeps on piling up, you can preserve a very good picture of past landscapes and environments. So one can imagine that the foundations of New Orleans, some of the the drainage, the electrical, the sewage systems, of foundations of buildings, which can go back tens of meters and which are made of reinforced concrete and brick. A lot of those can survive. They will change, once they're buried deep down, but nonetheless, paleontologists know how to reconstruct, structures like that. So yes, we will leave a fossil record.
And Jan, from a geological perspective, is the advent of plastics a game changer of sorts, given what we know about what happens to plastic over relatively long periods of time? I mean, I imagine this scenario where I don't know how many years from now, somebody could be left with the impression, if they dig up the United States, for example, that the big McDonald's M was representative not of a fast food restaurant, but of some kind of incredibly powerful king or something like that. I mean, talk to us a little bit about whether modern materials are changing what we will leave behind.
Well, again, a great question. Plastic is probably not a game changer, but it is an important part of the various novel types of chemistry and structure that we humans have made. And there's been nothing like plastics, in the past 4.5 billion years of history of the Earth, of that particular kind of chemistry, those particular kinds of polymers. And there's a lot of them. We've made something like 5 billion tons of plastic, so mainly over the last 50 years. And we know they're durable. We know that they can last for tens, probably hundreds of years, and probably thousands and millions once they're buried in strata. There are other things as well. We make yet more concrete. Again, concrete is a particular kind of rock that has only been made by humans. And we've made something like 500 billion tons of concrete, enough for about a kilo for every square meter of the Earth's surface. So we're producing large amounts of what we can call novel types of mineral and rock, and fossil indeed as well. And those are part of, if you like, the signature that we are leaving everywhere over the surface of the Earth, and that will get incorporated, into strata now forming, and strata that can preserve for millions of years.
So let's talk a little bit about the specific characteristics of the Anthropocene. Sort of a two-part question. Number one, in what ways are the sort of current status quo of what we are doing to the planet different than what humans have done to the planet in the past? And number two, what do you say to those who generally, when presented with a hypothesis that either to the climate or to the planet, or described however, humans aren't really doing anything, any changes that we can sort of quantify today are just part of a natural cycle? We hear that from climate skeptics in many ways. Address that generally, if you can.
Sure. Yeah. There is, I mean, scientists in general, and geologists in particular, I think, are getting increasingly good at making these kinds of comparisons between present and past, to say what is a natural variation and what is really different. For instance, if we look at, for instance, the composition of the atmosphere, which we know has an ability to change, if you like, the temperature at the Earth's surface, through the proportions of radiation that it can either trap or it can release. We know that the amount of carbon dioxide, in the atmosphere is now higher than it has been for at least 800,000 years, because there are layers of ice and snow in Greenland, and particularly in Antarctica, where you've got in effect fossil air, which you can drill down 4 kilometers through solid ice and extract little bubbles of air from that, and get a record of history of both atmospheric composition and through different types of chemistry of climate, how climate has gone up and down. And we know that as temperature has gone up and down, so the amounts of CO2 in the atmosphere have gone up and down as well. And we know that the last time we had this amount of carbon dioxide in the climate was about 3 million years ago, in the Pliocene epoch, when temperatures were a few degrees higher on average, when sea level was somewhere around 10 to 20 meters higher than it is at the moment. And we have a record of going back even longer to events again in the past, where there have been perturbations of the carbon cycle, which have been accompanied by changes to climate, by changes to the animals and plants and the populations. There have been extinctions, species radiation, things like that.
Now, Jan, couldn't someone say, and I ask this merely as to sort of fully understand, could the argument not be made, hey, what if we're just in a sort of 3 million year cycle? I mean, when we're talking about geological time and planetary time, these are huge time durations. How can we say with certitude, if there was a point 3 million years ago where we had this level of temperature and carbon dioxide in the atmosphere, could it not be a very long natural cycle?
There are, what we can see, again, if we look at the way, there are cycles of different periodicities and different rates, and some of the cycles that we can see, there are cycles of 20,000 years, 40,000 years, 100,000 years, which are due to basically astronomy, variations in the Earth's spin and orbit, and these are picked out very well by climate variations and also by variations in things like the amounts of carbon dioxide and methane in the atmosphere. Now, if we track, let's say, simply just take one aspect, which is carbon dioxide, again, not the only part of the story, but a big one. The rate of increase in carbon dioxide in the atmosphere, we can quite unequivocally, it's over 100 times faster than it was even at the end of the last ice age. When it over several thousand years, it rose by about 100 parts per million. Now, since the Industrial Revolution, it's increased by a similar amount and more, in fact, in the space of just a couple of centuries. And we know of no comparable rate or speed of increase in the geological past. There might have been far, far back, but we simply have no evidence of that. Where we have better evidence, in these last, particularly the last 800,000 years, we can see nothing of that scale and speed. So, however it pans out, and the smart money is that yes, it is beginning to, and it will further warm the climate. It is a very distinctive type of change, to the Earth. It's one of a number. The Anthropocene is not just about climate. In fact, climate is currently a relatively small part of the array, the spectrum of changes of the Anthropocene. But if we take the change in the composition of the atmosphere, that can be shown to be extraordinarily rapid.
Well, hard to argue with those numbers, no question about it. I've been speaking with Jan Zalasiewicz, a geologist at the University of Leicester. Thank you so much for talking to us about this.
Okay, thank you. You're welcome.